Alright, back again. Sorry. So this is really only for people who are really interested in these details about interferometers and the lensing, because I'm going to hopefully get to it. The guy posted a link to the actual paper submitted, and yeah, it needs to be read line by line and exactly illustrate how, if this is your definition of good science, then you're proving my point. Just completely proving my point, because it's absolute rubbish as science. So we'll get to that hopefully. France Teller leaves a time code again. The rings in your videos don't even align with the light beam. It doesn't have to. They're two separate beams. So I did the experiment demonstrating the interferometer. So I had the laser go through and I had the laser reflect. I didn't block either path. And I showed the pattern exists, and if I block one of the paths, then I block one of the beams. And if I block the other path, I still have the ring pattern. So one path, one half of the beam is creating a ring pattern, the other half isn't, for both directions. So the one that goes through, straight through, alright, creates a pattern. The one that reflects doesn't. And then in the opposite case, it's exactly the opposite. But the fact is that the beam that always goes through creates the pattern. The one that reflects doesn't. Okay. So then you post time codes. You can see the rings are not centered at the laser beam. Yeah, I wasn't at all concerned about centering anything. And the rings are centered on the pattern that's centered. So I'm just saying the only distortions that could possibly exist are angular distortions. Like it could be a little bit shooting up or a little shooting down, and you might get some distortions, but it's clear the pattern is perfectly fine. It cycles when I move the can. I mean, all these things are illustrated in the video. He's posting, essentially quote mine time codes here, saying I said this or I said that. Well, clearly, in 3 minutes later, I show you something quite clearly. And he keeps asserting that this somehow makes a difference. So he says, you said you're putting your hand to block one of the beams and the pattern doesn't disappear. It's absolute nonsense, okay? The pattern, obviously when I block one beam, the pattern doesn't disappear. When I block the other beam, the pattern disappears. They're two different beams. Okay, this demonstrates it's not the same cause. So again, just nonsense. You keep talking about a cause. I don't have to demonstrate a cause here. Your assertion is, I can give you the quotes of the talking head scientists, okay, paid hundreds of thousands of dollars to know something about physics, and I can quote them saying, we can recognize an interference pattern. We know this pattern. Right? Whenever we see this pattern, we know what that means. That's interference. Blah, 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 blah. Clearly, you're the one saying all patterns are interference patterns. I'm clearly illustrating that I can make exactly the same pattern. I can make it do exactly the same thing, and there's no theoretical mechanism for the interference. That's what I'm demonstrating. I'm demonstrating your pattern that you claim is an interference pattern isn't necessarily an interference pattern. Now it's your obligation to prove how the two patterns are different and why your pattern is interference and how my pattern is something else. You're not demonstrating any of that. You're not showing any reasoning behind that. None whatsoever. You have to explain how my pattern can happen without interference. That's your obligation. Amazing. The image of the pattern is the same, but the cause is different. So I guess at least he's sort of conceding. So here I'm going to play this part of the clip just to demonstrate exactly the point. I mean, he's saying there needs to be aligned. I'm saying it has nothing to do with alignment. I have the pattern with only one beam.
So the hard dot has lines, the absent dot has rings.
Right, so when I block one path I get a solid dot. And the dot does actually have lines, which is curious. I mean, probably a defect in the glass or the mirror or something, but it's there. It's something. And then when I block the other beam, I get the pattern. So one beam is blocked, full pattern. That's the point being illustrated. There's no recombining of photons. I've blocked the path. It can't recombine. There's no photons recombining, yet there's a pattern.
So I have to figure out what that is. So you can see the two aren't in alignment. When I block the other one, you can see that. See, the two are a little bit off here. So, let me go back a little bit.
Alright, you can clearly see the one beam has the pattern, the other beam just has the lines. And when I block the one that has the lines, you see the pattern. When I block the one with the pattern, you see the one with the lines. Clearly, two separate patterns being created by each beam, and they're obviously not interfering with themselves to create the pattern.
You can see, so they're not in perfect alignment. But even when I had them in perfect alignment, it didn't change anything.
So I'm telling the truth. I have aligned them. The two beams were right on top of each other, and it's exactly the same appearance. It doesn't change in any way whatsoever. So it doesn't have anything to do with aligning the pattern, the thing going this way with the thing going straight through and back. Doesn't change anything.
So one beam has circles, one beam has lines. That's a difference right there. That's kind of weird.
Okay, one block. So I'm blocking.
Circle, lines. See that pretty good?
There. Okay, I now block the one with the lines. Perfect pattern. So one of them's being blocked, entirely blocked. Pattern. Interference pattern. So why is it the same pattern you're claiming can only be created by the special circumstances of photons being recombined? That's my contention. Your whole theory is based on your argument and science's argument over many, many years. They keep saying, this is an interference pattern. This is caused by. I'm showing it's caused by something else also. Now you have to explain why you're doing something that this isn't doing. This isn't brain surgery, and you're just being a fucking a fact denialer here. Okay. The names refer to the causes, not the look of the image. So again, it's always been about the look of the image. They're always talking, it looks like interference, and that's all you've ever gone with. That's all that the science is based on, is what it looks like. So don't pretend that you can just evade this problem by just saying, well, it's different. I don't care what it looks like now. It doesn't prove anything. Well, it certainly does prove that if you're going to say you know it's an interference pattern, you have a little higher burden of proof now, because it's not exclusive to interference. So you have to explain how you know it's exclusive to interference in this case, and not exactly what I'm creating, without any interference. The MM pattern would appear only where the laser beams mate. So again, that's what you say. Again, an experiment done with a telescope. The beams were shot into a telescope and looked at through the naked eye, through a telescope. That is, it wasn't the whole pattern, it was just the center of the pattern. The MM pattern would only appear if both beams are unblocked. Right, because it's only looking at the center of the pattern. So all it's looking for is when either pattern has a solid or bright. So there could be lots of circumstances where both patterns are dark or both patterns are bright. That's not looking for the answer here. That's not looking at the pattern. This is counter to the content of your videos. I'm saying everything in my videos is talking about what interferometers produce, like the ones on YouTube. I'm saying the pattern I'm creating is exactly the same pattern they're producing by a different method. And the point is, if I can create the same pattern with a different method, you can't again claim exclusivity, that this pattern proves interference. It's clearly not just an interference pattern, it's clearly a pattern created by other circumstances. And you have to account for that. You don't have any right to say it has to be an elephant because it's an elephant print. I've made the same print without the elephant. Now you have to have more evidence that it's an elephant. You can't understand that? The confirmation bias is beyond ridiculous. That's exactly what you are. You are beyond ridiculous. You're a huge waste of time. The facts have been demonstrated. I fucking went to the trouble of videotaping. I did the experiment, and you're still whining that somehow I haven't demonstrated the case. I've demonstrated the case that I can make your footprint without a fucking elephant, so again, you have to prove somehow that you know it's an elephant. And your proof is weak, thin, and non-existent. You're beyond ridiculous to keep claiming that I'm being unreasonable because I don't accept your fucking dogma. You religious fucking kook. You dogmatic, authoritarian fucking ignoramus. Who the fuck do you think you are to insult somebody else's intelligence because they don't accept your fucking bullshit? And have proved it to be bullshit. You haven't proven a fucking thing. And you argue they're always huge unless you reduce them. I argue that the pattern of diffraction is huge. That's right. It's apparent in the experiment. The light only travels frickin' 2 meters, and the pattern is this big. Yeah, that's a hell of a lot of divergence, jackass. Concave lenses expand laser beams, retard. Pretend to believe whatever you wish to believe. I'm just saying, if you think they put concave lenses in into the experiment, show me the experiment where they put a concave lens in. Show it to me. You're demonstrably wrong. Demonstrate it then with a fucking video. Where's your fucking evidence? Oh, that's right, you don't have any. And I pointed out in my video, look how easy it is. Now that's me quoted, and he says, that's reason for why it's not MM pattern, not the whatever that is, quantlet pattern. What are you talking about? It's exactly the same pattern, it's exactly the same footprint, and now you're saying, I'm just claiming special rights. I know it's an elephant because it's an elephant print because I'm claiming special rights to claim it's an elephant print, not your pattern. That's all you're doing. You don't have any evidence that yes, it's an elephant print because I have the elephant right here. Are you showing the elephant? Do you have a video of the elephant making the print? Do you have any evidence to establish that your assertion that your print is really an elephant? Do you have any evidence to support that claim? No. All right. I'm not trying to distort and pervert. You're not very good at that. So again, some claim that I perverted something in the experiment, that somehow I deceived you. I wasn't really blocking the beam. I was really putting mirrors in and doing some kind of trickery. So exactly what do you want me to do? Exactly. To verify that I haven't fudged it at all. Redo the experiment 10 or 12 times with, I'll have the governor of the state show up to say, oh yes, well, Gary didn't use any mirrors. I mean, you're such a petty fucking little twatty cunt to make these fucking veiled accusations. No evidence, just a veiled accusation. You're fucking a troll. You're a fucking little dickless weasel. I mean, if I could punch you in the face, I fucking would, you piece of crap. Who the fuck are you to make accusations about my integrity or my honesty, you piece of shit? Why don't you fucking out yourself, you lousy fucking troll? Alright. Unless the flat earthers have evidence relevant to their theory. If the video is an example of your evidence, so it cannot, it's a videotape, he's saying it's not good enough evidence. I don't know. There's no pleasing this lying piece of shit. Okay, then you basically have nothing. Okay, I'm not even going to read anymore. This does not deserve my attention. You fucking little weaseling, slandering, lying piece of fucking goddamn cunt shit. If I am ever proven right, I'm going to use my goddamn... If I win the Nobel Prize, I'm going to use the money to sue your fucking ass off. You fucking piece of shit. You're just such a weasel. You can't figure out what a fucking weasel you are. I go to all this trouble to demonstrate the point, and then you sit there and pretend. I don't have to accept that as an experiment. What the fuck? So Chris Rock, which is again is the cowboy, post a link to a text video of scrolling text. I will not do that, so fuck you. If you can't find some way to post text on the internet, you could have posted it as the comment here, right? I mean, rather than a link to a scrolling video. I'm not reading scrolling videos. Fuck you, go to hell, you retard. Okay. He's persistent, isn't he? At least he's conspicuously pig-headed. Whatever. I don't know exactly what that word's supposed to be, but I don't think that's a word. Even with my bad eyesight, I don't see a word there. Alright, so there was a comment by somebody who posted the link to the thing, but he must I don't know, I guess when I deleted the other guy's comment, his comment disappeared. So anyway, I'll repost the link to this PDF. So this is the submitted paper for having done the solar lensing experiment. So I'm going to read it through because there's no point in quote mining from it. The whole article is a steaming pile of shit. Alright, 1919, Sir Arthur Eddington attempted to measure starlight deflection caused by the sun's gravity. Okay, he was trying to test Albert Einstein's recent calculations based on his general theory of relativity, taking advantage of a total eclipse of the sun to image stars. So let's understand. Einstein's theory of relativity speculated that because light moves at the speed of light, it is now time dilated, and therefore, when you calculate the effects of gravity on a photon, you can double the effect because the photon is in the gravity twice as long. So Newton, who didn't believe in general relativity, his number was 0.8 arc seconds of deflection would be possible if photons are material. And Einstein doubled it to 1.7, whatever the number, 4 or something like that, arc seconds. So let's also understand this context. I might as well say it now instead of later. This number 1.7 is the number that would happen right on the surface of the sun. And by the laws of gravity, the inverse square law, as you go radiuses away from the sun, you essentially have to divide that by 4. Now, they only divide it by 1. Okay, I mean, cut it in half. But clearly the inverse square law means 4 times less the gravity. So clearly at one radius you have 4 times less gravity. That's a fact. So clearly you would have 4 times less deflection. They're only considering it as 1 times less, 1/2 less. But it doesn't really matter. So just understand that the real number that they can detect has to be at least a number that's more like 0.5, because they have to be far enough away to get away from the corona. So let's understand, the edge of the sun is where 1.7 is. As you go away from the sun, that number gets smaller and smaller and smaller and smaller and smaller. Alright, now, arc seconds is a nice term. It's all friendly and fun. But let's understand what it really means. Arc seconds mean point. So 1.7 arc seconds means 0.00047 degrees. 0.00047 degrees. Tiny, tiny. Let's understand, the sun, as you see it in the sky, its size takes up 1/2 of a degree. So the total distance of the sun is only 1/2 of a degree. And you're going to find movements, aberrations, that are 0.00047. And that's the ideal. That's on the surface of the sun, which you can't do. So now you're down to 0.00025 as maybe a possibility. A tiny amount of offness. So this whole experiment is just as a theoretical thing, even with an eclipse, through the Earth's atmosphere, is I think, a theoretical non-starter. In atmosphere, you can't even do this experiment. It's impossible to do. So anyway, let's play along though. Alright, sorry but I just want to get that out of the way. So when you hear these arc-second numbers, recognize how tiny this amount is. This tiny bit of change on the piece of paper. A 10,000th of the sun's width. 1/10,000th of the sun's width is what they're trying to see how a star's difference in position. An insanely tiny amount of distance. Okay, sun image stars. The deflection should appear rapidly from the center of the sun, radially, from the center of the sun, and decrease as the reciprocal of that distance, with a coefficient of L equals 1.75 arc seconds. So this is part right here I'm saying this doesn't even make sense. Okay, the coefficient is the inverse square law, which means as you move a radian away from the sun, it's 4 times less arc seconds, bending, gravity. 4 times less stuff is hitting the line and bending it. Fact. It has to be a 4-time decrease in the arc seconds. And they apparently can't do that math right. I can't see how it's possible that that math is correct. Well, anyway, so with a coefficient of L equals 1.75 arc seconds for a star in the sun's lamb. So the sun's lamb is the surface of the sun. The lamb is really just where the edge of anything gets fuzzy. But it's at the sun's surface. That's what the sun's lamb is. So your 1.75 is at the surface of the sun, and every radius of the sun you go away from there, you have to cut that number in quarters. After detailed examinations of several large photographic plates, Eddington concluded that Einstein was right. Well, let's understand, he only got 7 total plates that were any good. Most of them got destroyed, blah, blah, blah. The ones that he got, a couple of them were too blurry. Really tough. He expected to get plates that had 10,000 stars on them. He got plates that had 1,000 stars on them. But clearly a lot more stars than this guy got, which is so ironic. Okay. His pronouncement made Einstein a worldwide celebrity and a household name. Right, even though the pronouncement was really just made out of complete bullshit. Over the years that followed, however, after similar measurements taken in later eclipses, the measurement's uncertainty in the deflections was never reported better than 6%. The fact that they report these error codes, you can see that it doesn't really mean anything. When people say, oh, these results have an error of 6%, they're just making that up because frankly their error math is insane also. When you have a 30% error in some fundamental part of your experiment, in the very beginning of your experiment, and then you have a final result that says 3% error, clearly you fucked up somewhere because that 30% has to show up in the end. Any big errors in the beginning have to be in the end. You can't make them go away. And apparently this guy does make them go away. Anyway, some of the experiments have been reanalyzed in an attempt to remove perceived biases in favor of Einstein, making those results much more uncertain. Yes, so reanalyzing still makes them fairly uncertain. That makes a lot of sense. Not until 1970, error radio frequency measurements. So now, completely different kind of science. Okay, I mean, radio frequencies, you're not imaging, so you can see scatter. Okay, radio waves get through scatter intact, but you have no hope of having accurate positional data. Radio waves have no resolution, almost none. The resolution is just blobby, and so you can't possibly use that data to detect lensing because it's so subject to scatter. The corona makes a mess out of radio waves, so it's always going to, you can't eliminate what's scatter from optical resolution because there's no optical resolution. So that, this is just showing this guy's bias, that somehow radio wave experiments somehow validate something when it can't be used to detect lensing because it's way too low resolution. Some experiments have been reanalyzed. Okay, I did that part. Radio measurements and recent astrometric satellite measurements where Einstein's deflections precisely measured. So again, they're using all of this high-tech crap with lots of mathematics and lots of simulations and lots of processing and blah blah blah, and they say this is good science. I say it's just incredibly bad science. Shows the result of an initial report for every eclipse experiment, figure 1, as well as the newer radio frequency experiments. So this chart is absolutely useless. It's just a piece of mush. So they're just trying to point out that somehow they're getting narrower and narrower with their technology, but there's no real comparison between a good optical experiment and a radio wave experiment. Again, you can't tell the difference between scatter and gravitational movement with radio waves. The two of them are the same, identical. There'd be no way to tell whether it got scattered or whether it's gravity. You can't tell the difference. There's no theoretical way to distinguish, where optically you can. Alright, the relative value of the deflection coefficient is the uncertainty are shown in optical red. Yeah, so I won't bother with the chart because it illustrates, even if you could figure out what it's saying, it still doesn't say anything. And it mentions the Hippocampus satellite or whatever, which again is a completely strangled version of the experiment. I mean, just insanely low resolution in terms of just using algorithms to figure out whether you've got all the jiggles of all the stars in the universe, and somehow now you know how much a star jiggles by average, and therefore you can make some assumptions about how much lensing is taking place in the universe. It's just theoretical garbage. Alright, the measurable stars closest to the sun have deflections typically 0.3 arc seconds to 1 arc second. So he's conceding, okay, that the closest suns they can use, we're going to have an arc second, a usable arc second number that's going to be much below that 1.7, which means it's much below 0.00047 degrees. Something much below that is the only realistic expectation. Alright, in order to measure these with even 10% precision, so I don't think he claims 3% precision with his results, and I'm saying he hasn't defeated any of these errors. The location of the stars need to be determined to within 0.303 arc seconds. So just think about what he's just saying here. To get 10% efficient, he can be 100 times off. The real number is 0.00027, and he's saying it's okay to have error of 0.03 to 0.10. Well, those are arc seconds, so again, sorry. I have to convert those into degrees to make my argument. Okay, so I'll concede, but they can't get it. So just think, 0.03 arc seconds would be 0.0000, okay, 0 degrees. I mean 5 degrees. I mean it's 1,000 times smaller than that 000 number. And he claims he can see things in those ranges. He can detect something that small. He can detect a change in degrees of 0.00005. That's his claim. That's somehow a realistic accomplishment, and then he can get rid of that 10% error. You see, this is just insane. These small numbers are what makes the experiment so difficult. Yeah, and I don't see how you overcome those facts. I think you're dead in the water before you even start. From 1919 until the last successful measurement, it's another successful measurement, bullshit, in 1973 and 76, optical measurements during 7 total eclipses used the best available technology, who cares, And he's claiming he's using the best available technology, which is complete nonsense. This meant large photographic plates, so he's conceding that everybody else was smart enough to say we need as high a resolution as possible. Apparently he didn't. Long reflector telescopes, which he didn't need that either. So these are 8.5, what? 1.5 meter to 8.5 meter focal length. I don't know. I haven't heard of this 8.5. That's a long telescope. Anyway, and comparison images taken, I think Eddington's experiment, I think, was 12 feet, I think. And comparison images taken with the same telescope a few months before and after the eclipse. So he mentions that. He doesn't talk about it much, but he doesn't do that. No comparison photos were taken. So, I mean, isn't that right on the face of it? Just bogus. Like, he couldn't be bothered. He's going to go to all this trouble, and he couldn't be bothered to get the extra data of taking photographs of the same piece of sky 6 months later to have a control. I mean, it's just saying I'm going to do the experiment without a control. Isn't that just obnoxiously stupid? All right, anyway. All right, this meant large photographic plates, blah, 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 and comparison images taken with the same telescope a few months before or after the eclipse to determine, 6 months actually, to determine non-perturbed star positions. I don't know, 6 months makes sense to me. I mean, it seems to me that's always half, so it really has to be 6 months, always. Non-perturbed star positions. So you need the control from the same exact location, so just in case something is moving or doing something, you'll have the same perspective at those things. You really need the same point of view to be able to measure distances between things, because all the things are different distances from each other. One of their key desires was to take plate scale calibration images during totality to remove one of the largest error sources, larger than the 10% one, or the 30% one that he'll get to eventually. Astronomers attempted several innovative techniques, including the use of beam splitters. Well, as we've talked about, that's not necessarily a good thing, is it? To simultaneously image these calibration fields. The experiments were always very difficult, resulting in technical failures. I think it's a useless pursuit. I mean, I think the basic plan of having control photographs and then superimposing your photographs on top of them is about as good as you can get. Weather caused some of the problems, of course, but the 20th century astronomers always hoped that someday the experiment would be completed without errors, providing much more accurate results. See, he thinks he did it without errors, even though he never took a control photograph. I think that's an error, frankly. The recent 21st of August 17 total eclipse across the United States provided a convenient opportunity to repeat the experiment. Yeah, too bad nobody did it, including you. This paper reports successful starlight deflection. Woo! He's reporting it, but I don't think he can defend it. Measurements performed in Wyoming using high-quality amateur astronomical equipment. The final results showed the most precise and accurate measurements of this kind ever reported. So he say they show that, but he just says it. I don't think he can back it up. I don't think this paper has any scientific integrity to be able to say he has this tiny error. The calculated uncertainty is only 3.4%. I think you calculated poorly, suggesting the deflection coefficient L is likely to be between 0.69 arc seconds and 1.8 arc seconds. So he's just using the standard on the sun's surface number to project that if his star was at that location, that would be the deflection. So clearly he's saying he saw deflections that are much smaller than that number, and he's just accelerating them to the standard, that they're consistent with the standard at that distance. I will argue that their mathematics is broken because they're not appreciating that the inverse square law doesn't allow you to just cut your your angle in half, you have to cut it in fours. 1/4 the amount of deflection 1 radius away. The final coefficient was measured to be 1.52 arc seconds, which is within 0.05 of the theoretical value. So he's just going to claim that, well, my number is this, and so it's so close, you know, very close. And he's talking as he's all these zero places. So understand that those zero places, when he goes 0.1752, that 2, right, 0.002 arc seconds. He's claiming that he has an accuracy that fine, which means in degrees that is 0.0000000 degrees. Do you really think he got to the 10,000th degree? I don't think he has any hope of doing that. Alright, anyway. I mean, this is bullshit. On its face, that is just bravado, or whatever you want to call it. That's just some kind of bizarre arrogance. One of the key improvements that simplified the experiment was the availability of absolute star positions with 0.002 arc-second precisions. So he's claiming that the synthesized star chart can duplicate the stars at his location from the exact location he was looking at the sky, and it's a better image of the stars than he would do with his telescope. So he's saying that's the precision. I'm saying I don't buy that for a second. Again, 0.002 arc seconds means 0.0000005 degrees. I don't buy it. I think that's just, on its face, absolute crap. This estimated star measurement of comparison images taken months away from the eclipse thus eliminated some error-prone data analysis steps. So this eliminated star measurements of comparison images. So he's basically conceding, okay, we didn't bother with comparison images because that's too much data. That data just breaks the experiment, right? Extra data, bad. Small data, good. Extra data, bad. More data, bad. That's all he's saying here. Somehow, more data would have broken his experiment. It would have just gotten in the way. It would have just been a terrible nuisance to actually have more data. I mean, is that a scientific approach? Is that what scientists think? Extra data? No, 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 that's terribly dangerous. We don't want to deal with extra data. I mean, that's what he's saying it clearly. It fixed one of our errors, having a control. You know, that's what he's saying. This eliminates star measurements of comparison image taken months away from the eclipse, thus eliminating some error-prone data analysis steps. So he's basically saying the comparison to an actual image is bullshit and wouldn't have provided any insight. I mean, I'm sorry. I'm going to duplicate a guy's experiment by not duplicating the experiment at all. Eddington's experiment is fundamentally the comparison of two exemplars, two images taken 6 months apart. That's what his experiment is. So you're really not doing Eddington's experiment. Alright, anyway, corrections for atmospheric refraction were still needed, but those were easily calculated from local weather measurements. So again, he doesn't have to put the telescope in the location, and it doesn't have to look through the same sky, and it doesn't have to do any of this stuff. He'll just use software to give him the right answers, instead of actually forcing the telescope to be there and look at that piece of sky from that exact angle. He'll just trust that the synthetic facts are good facts. Fuck getting real facts. Just use the synthetic facts. They're so much more fun. Anyway, hence, this particular trial had fewer obstacles to reach high accuracy. So that's his sentence. Can you believe it? Hence, this particular trial, because we didn't have more data, had fewer obstacles to reach high accuracy. The extra data of control photographs just would have gotten in the way of accuracy. What? For that sentence alone. No. Sorry. Too silly. Alright, anyway. Using current technology generated 2 new problems. We had more than 2, I would say. Atmospheric turbulence apparent in short exposures causes star images to wander randomly between frames. So this is a wonderful idea, right? Yes. Okay, so we have this idea that if you take a short exposure, the images are actually bouncing all over the place. And so your short exposures will just catch it in wrong locations. And the trick is that the image has to actually be randomly bouncing, and it doesn't randomly bounce. It's like heat waves. You know, when you look on a hot day and you can see how the images are being warped, they're warped in a pattern. They're not warped randomly. And the same thing happens with the atmospheric problem. It has pattern in it all over the place. It's not randomized. So he just doesn't even understand this error completely. Alright, anyway, randomly, so he says randomly, wander randomly between frames. It's not random. Not even close. You know, I mean, every location has different atmospheric conditions. And so there's nothing random about which way the wind's blowing, which way the air is moving in the atmosphere. None of that is random. It's very specific. Alright, the magnitude of this effect depends on the atmospheric seeing, exposure length. So the atmospheric seeing is, yes, how fucking full of water molecules the atmosphere is, lots of other things. And clearly those are all going to create non-random effects. You think a rainbow is a random effect? Clearly not. Exposure length and telescope aperture. So yes, well, exposure is essentially telescope aperture means resolution. Yes, the more resolution you have, the better off you're going to be. All right, each star's motion is uncorrelated. Okay, that seems reasonable. Stars aren't connected to each other by umbilical cords. True. Since they are separated by relatively large angles from each other, well, they're not that large, but anyway, the apparent motion measured 0.4 arc seconds RMS for the 0.62 second exposures. So he took basically half-second exposures. So all the past experiments, the exposures were 15 seconds long. I think Eddington's were, I think they were something like 15-second long exposures. I think that's about right. Long exposures, lots of photons. Short exposures, very few photons. So this is a resolution concept. So he's somehow going to argue here that short exposures is more resolution somehow. And he's going to use a stupid gimmick to do that. Alright, exposure during totality. So he took a bunch of half-second exposures of stars. So clearly this is why he didn't get 1,000 stars in his field, because the exposure wasn't nearly long enough to get multiple stars. You could only get the very brightest of stars, and that's it. No hope of getting any of the lighter, dimmer stars. Alright, during totality, comparable to their gravitational deflections. Alright, I don't know what I missed something somewhere. The apparent motion measured 0.4 arc seconds for the 0.62 second exposures used during totality, comparable to their gravitational deflections. Alright, so he's saying there was 0.4 arc seconds. Okay, so understand, the total amount of arc seconds you have to work with under ideal circumstances is 1.7. He's saying 0.4 arc seconds of drift. So get that, 1/3 almost drift. You could say at least 1/4. 1/4 of the ideal circumstance is drift. Now just imagine you're not in the ideal anymore. You go from 1.7 arc seconds to 0.5 arc seconds. And you still have 0.4 arc seconds of drift. That's almost 90% of your image is drift. Come on. And he says he has a 3% error. He has a 90% drift rate comparable to the control state he wants to achieve, the desirable state. He's got 90% drift from the desired focus, and he claims the whole experiment only has a 3% error. This is fundamental to the experiment. I shouldn't have to do this. I mean, serious people should just already, the astronomers should already know this can't be right. Alright, anyway. Comparable to, okay, all previous eclipse experiments use photographic plates. Well, that should tell you something. I think it's fine to use this new technology, these 20, 40, 50 megapixel cameras. They can handle this. And large focal ratios that eliminate this problem because the star's wander was integrated over the long exposures. See, the great advantage, look, long exposures don't create any problem because as the stars move, they create lines. And all you do is take the center of the line. It's a great advantage in a way. I mean, you know, all you have to do is find the center. And you just measure center to center. So all the stars are lines. And some lines are this long, some lines that long, whatever. It doesn't really matter. And you just measure from the center of one line to the center of the other line. And that will be accurate. But when you take a bunch of little short exposures, you don't get a line. You get whatever the atmospheric condition is, and you get a huge bias in a direction. So you get nothing like a line. You get a bunch of reinforced distortion. So you get a position that's way off from where the line would have been if you had a long exposure. He should have taken at least one long exposure to compare his short exposures to, because I think it would have shown that all of his exposures were off the line. Oh, man. Anyway. This is just such flawed science. I mean, look, and I'm not an expert on this stuff, but this is stuff that, you know, you can reason this out, right? These aren't unreasonable objections I'm bringing up, right? I mean, this is stuff you can understand that, yeah, that doesn't sound right. All previous eclipse experiments use photographic plates with large focal ratios and eliminated this problem because the star wander was integrated over long exposures. This burdened the star images but did not seriously affect their positions. Okay, so now he's talking about his. It burdened him not to have photographic plates and long exposures, but nah, he fixed it. Modern CCD sensors necessitate minimal exposures less than 1 second to prevent pixel saturation. A complete nonsense. Pixel saturation is irrelevant. It's like saying I took a picture of something and it was very white in the center, okay, because pixel saturation. Well, that's exactly what you want when you're trying to image things on the outside that are of weak resolution. So you want oversaturation on the bright objects so you can see the dim objects. There's no other way to do it. There's no way to see dim objects without oversaturating the bright objects. Theoretically, there's absolutely no way to prevent that. If you want to see the dim objects, you have to make the bright objects way too bright. I mean, it's just, you can't overcome that fact. Alright, so this argument is ludicrous though. Modern CC sensors necessitate, he says, normal exposures less than 1 second. It's just idiotic. I've taken fucking 3-minute exposures in my backyard. The camera didn't blow up. I mean, it's just such bullshit. To prevent pixel saturation. Pixel saturation would be just fine because it would all be in the right location. The pixel saturation would happen in the center of things. That's exactly where you want the saturation, is in the center of things. It would not be a problem. Anybody who does astronomical photographs has to know that pixel saturation is not a problem. So all of the images were first aligned and then averaged together to simulate a single long exposure. So he thinks this is theoretically rational. I'm going to simulate a high resolution long exposure by taking a bunch of short exposures of common error. So we have so it's like me taking a picture of the little flowing vapor lines from something hot, and saying I can take a bunch of resolution pictures and somehow that will randomize the error, when all the error is in one direction. It won't randomize the error, it will solidify the error. You're just going to solidify the pattern of error. You're just reinforcing the error. You're taking one error, stamping another error on top of it, and stamping another error that's the same error on top of it, and taking the same error and stamping it on top of it again. You're not getting higher resolution, you're getting reinforced error. I mean, again, this is a theoretical problem here. This should have been fixed in theory. They should have fixed this before they even started the experiment. To think you're going to create a high resolution image out of a bunch of low resolution images is not very logical. Unless you're using them like low resolution of one section and you put this section, like you take a snapshot of this and then 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 this. You can do that to create high resolution, but you can't put images on top of each other and create high resolution. You can't take low resolution images and just keep piling them on top of each other and say, now I've created high resolution. It just doesn't work that way. I mean, my features would not get more precise if I took a bunch of low resolution pictures of me and put them on top of each other. I'm not going to get a more precise image of myself. I'm going to get a blurrier image of myself. Alright, anyway. This technique reduced the centroid measurement error. So he assumes he reduced some error with this technique. Okay, that pretends he has a high resolution image. Alright. I mean, this is, like I said, this is like kind of non-starter theory. I mean, come on. This isn't the Eddington experiment. She shouldn't be allowed to call it the Eddington experiment because this isn't the Eddington experiment. Alright. The other new problem was getting correct exposures. If they're only a half second, who cares? With photographic plates, the final image could be monitored in the darkroom during chemical development. Again, this is another problem that is not a problem. I mean, clearly, you can ruin your photographs by having the wrong exposure, right? So that's all he's really talking about. You don't want to overexpose the photographs or underexpose them because you want to be able to get as much detail as possible without creating flare. But clearly flare would be telling you something. So if any of the little suns are flaring hugely, then you would know you have way too much atmospheric distortion. So again, that would tell you something if things are flaring, if things are getting blurry. But again, you could just, you can almost have any setting on the camera as long as it's not insanely, the aperture is not way too open or way too closed, and the exposure isn't way too long or way too short. So I don't understand how this is a problem at all. The technician stopped the process before too much darkening ruined the image. With photographic plates, the final image could be monitored in the darkroom during chemical development. The technician stopped the process before too much darkening ruined the image. Too much darkening ruined the image? You mean too much exposure ruined the image? CCD sensors have a much smaller effective dynamic range. And again, it really doesn't matter as long as you don't way overexpose. I don't understand the problem. Short exposures make star solenoid positions uncertain. Here we go. So he's talking about the center, being able to ascertain where the center of the star is. Uncertain due to the digital noise while overexposing saturates some pixels. So again, I'd argue that it's really not a problem. The oversaturated pixels are confined to the center of suns, and so it really wouldn't be a problem. preventing accurate measurements. I don't think this is at all rational. The higher the resolution would have helped you fix that problem. You're using low resolution, that's why you have no hope of fixing the problem. Because yes, your dots, your pixels, are too spread out. Fortunately, oh here we go, current portable computers are fast enough to run an auto exposure program with only a small timing penalty. So again, this sounds a little dangerous to me. If you're changing the exposure for each photograph, that sounds dangerous. While analysis of images from previous ellipses was used to estimate the ideal exposures and led to predictions that made this experiment seem feasible, I'm implementing auto exposure contributed to the successful completion. So he says he has successful completion. His images are totally unviewable. There's no evidence that he captured a great deal of the star field, that he has anything called high resolution. So all of this crap is, in my opinion, just preposterous crap. Whatever he did, it didn't work in my opinion because his images suck. A review of commercially available telescopes, so this is equipment. I don't know if this is going to be terribly interesting, but let's do a little bit of it. And cameras led to selection of the TeleVue Optics Inc. reflector and the Finger Lakes Instrumentation Inc. blah 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 CCD camera. So again, I could have just said Canon 490 and the whatever telescope. So he's just basically got them for free. So he's promoting them. He's giving them their advertising, their free advertising. Yeah, it's all for free. Everything's done for free because the advertisement's there, right? So that's the free part. Technical criteria are detailed in this section. Table 1 summarized equipment parameters, and Figure 2 shows location in Wyoming. Well, just looking at the telescope, it looked to me like it's a little underpowered. I think you needed something bigger, especially if you're only going to take half-second images with a 6-inch frickin' telescope. I don't understand how you could possibly collect enough photons. Alright, so this is the model. This is all just those details. Here's him. This is the location. La la la. So look at the telescope. I'm just saying, what is that? It's 5-inch. And it's a composite telescope, right? Meaning it has more than one lens in it, right? I think that's what it is, right? Compound. It's a compound lens telescope. Compound lenses are a real problem when you're trying to get something where each pixel is not fucked up. The more lenses that the light has to go through, the more error you're creating in your locations. So isn't that a downside? I mean, I think the editing thing, the whole point of having the long telescope was you only have one lens, and one focus. And so you have fewer lenses, meaning less distortion. I think that's the optimal condition. I think a reflecting telescope would have made more sense in my opinion. Because, you only have the one big lens and then the little, turn the light in view. And clearly, you obviously don't, the fact that it would zap out the middle is perfect because you don't have anything in the middle anyway. Alright, comparing different CC alternatives led to the use of monochrome interior sensor, interline sensor. This guaranteed identical exposures on all pixels and avoided potential shutter and vibration effects when used with short exposures. So again, I don't think you have any real vibration effects if you use a timer. So again, you said you had the camera hooked up to the software. I don't see how there would be too many shutter problems, but whatever. The desired, I mean, especially when you're doing a half-second exposures. Why don't you do longer exposures? I still don't understand half-second exposures. He couldn't have done 2-second, 4-second. Why half-second exposures? How is that reasonable? The desired field of view needed to be large enough to contain nearby stars out about 5 solar radii. So this is the argument for your standards have to be in weak enough gravity that they didn't move or they haven't been diffracted. But again, understand the argument. The gravity trails off at a rate of, for every time you multiply the distance, you cut the gravity in quarters. So certainly at 5 radiuses, you got pretty small amount of gravity. But the point is if you're comparing it to something that's only in, that's 2 radiuses away, that's pretty low gravity too. And you're back to this 0.000003 degree kind of detection, which is impossible. Alright, anyway, when used for short exposures, the desired field of view need to be large enough to contain nearby stars. Okay, yeah, no, sorry, that 5 solar radii are 1.3 degrees from the sun. So we've already established the sun is a ½ degree in total diameter, so that's about right. Well, 1.3 is only actually 3 solar radiuses away from the sun, so it's certainly not 5, so that's not exactly correct. Using a large array would have added significant overhead. Well, no, see, a radius of the sun would only be 1/4 of a degree, 0.25, so yeah, his number's way off. Added significant overhead time by no, that's right. That's to his benefit. Never mind that argument. Overhead time by imaging stars that had very small deflections. Added significant overhead time by imaging stars that had very small deflections. So he claims he images stars away from the sun that are less deflected, but clearly at half-second exposures they can only be the very brightest of stars, probably contributing only noise to the solution. Well, that didn't even make any sense. So he collected images of stars far away from the sun, but they're noise. Okay. A monochrome camera allowed more accurate centroids. So he's claiming somehow that a color image would have had a less resolvable center, so that somehow you couldn't tell where the center of the circle was. I don't think it would make any difference, but who cares? The camera needed to be cooled to reduce thermal noise. I don't know if that would. I don't think that innately makes any sense either. Clearly, you're just trying to capture the resolution, and thermal noise from heat. There's no evidence, as far as I understand it, that it creates anything but random distortion. Random distortions are good. Non-random distortions are bad. So I don't think there's any evidence that photographers have a huge problem because their images are distorted in non-random ways by heat. But who knows? The only sensors that met these requirements were on the, see, he's just selling the camera, semiconductor blah, blah, and the Sony blah 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 series CCD used by several vendors in their astronomical cameras. The author had previous experience with a Finger Lakes Instruments camera, so that model was chosen. I just find it very hard to believe that the professional photographers who are taking photos of all kinds of things at very long range with very huge lenses don't know what kind of camera to use to take a high resolution picture. So this idea that an astronomical camera has to be fundamentally different, I don't think I buy that argument. A 16-bit readout is used in the camera, providing output signals from O to whatever analog blah blah counts. Only one digitizer connects to the sensor, so the entire array is read with the same gain. And it doesn't really matter if it's only a half-second exposure. Okay, to reduce chromatic aberration from the telescope, as well as to reduce atmospheric dispersion differences between different special class S whatever filter from blah 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 was bonded in place just in front of the camera sensor. So they put some special sensor inside the camera, which doesn't sound too good to me, special filter. Just sounds like one more thing to fuck around with this experiment. This filter also increased the contrast between the blue tinted sky and the redder stars, which made up most of the measurable targets. So again, he claims with this filter he has better seeing. Okay, maybe, I don't know. I mean, certain kinds of light, I imagine, filtered out would make sense. Ultraviolet versus infrared or something. Getting rid of the infrared might make more sense to get a higher resolution. But again, I claim the short exposure already killed this subject. There's no point in talking about resolution because you already killed it. Reducing the amount of light into the sensor slightly increased the exposure time. And, well, what's the difference? Because your exposure time again is insanely low, and I would argue for no good reason. But this actually reduced atmospheric turbulence effects. Alright, we have to read that again. Reducing the amount of light into the sensor, which sounds bad idea, less light, less photons, less image, slightly increased the exposure time, but this actually reduced atmospheric turbulence effects. Well, it's such a slight increase in the exposure time that the reduced atmospheric effects would have been even more reduced if you actually increased the exposure time. So again, you're just making the argument again, pointing out how this short exposure is a real problem. Most of the camera time is spent on digitizing, downloading, and saving the images. So adding the color filter did not significantly affect the timing. Another weird point. So apparently the color filter was a synthetic software filter, which doesn't sound like a great idea either. Shows the sensor response curve and the red filter transmission. Now, I don't think I need those details. Let's see. The telescope mount needed to be portable, equatorial design, so the author used software, bisque ink, blah blah, Paramount. This computerized mount easily handles the mass of the chosen telescope and camera, and was easy to set up the matching tripod in Wyoming. So I would argue he's only taking half-second exposures, and somehow he's worried about the tracking of the telescope. I think clearly the whole eclipse can happen without the telescope having to move at all. I don't think you have to move a telescope during an eclipse, but whatever. You don't have to move it much, if anything. But clearly long exposures would have been better, and allow the drift to show. Allow the image to drift. Would have made more sense to me, a lot more sense, than to force to create the added error of your moving the telescope having to be being perfectly synchronized to the movement of the sun. That seems an unrealistic expectation. It's sub-arc second periodic error and all sky pointing accuracy assured a good images would be acquired. So he's calling them good images. Again, low resolution images of very few stars. Fortunately, a good polar alignment. Well, again, I guess I don't need to read this part. Let's see, software. I don't know, is that going to be a subject worth reading? Well, anyway, let's just go to the photos. Maybe I'll come back to this after I read all of that. I didn't read down this far yet. But his images are really pixelated, clearly, horribly pixelated, really awfully, horribly pixelated. I mean, doesn't post, I don't think, any full images. So there's no full images. You can't look at any of the resolution of the images, so no images are provided. His actual images, this is star chart images, so none of his actual images are provided except in tiny, I think they're here, yeah. So these are his images, and man, they suck. Can't click on them, can't enlarge them. So no high resolution images. And I mean, if you look at the old Eddington glass slides, clearly far superior to this. And I mean, the corona is huge. As I've pointed out, it's at least a radius wide in some cases. So you're automatically stuck with stars that have to be outside of that line. You cannot realistically say you have gravitational lensing if you're looking at stars that are in the corona. he claims, okay, let's go to his chart, I mean, because he claims that he was very close. So, let's see if this has the distances. It might be a better chart, this chart. Pixels, pixels, small number of pixels, of course. Alright, let's get to, I hope he has a better chart. So there's a lot to read here, obviously. Here we go. So arc seconds, distance from the sun in solar radii. So this is 1 would be, that's where you have 1.7. So 1.7, yeah, I can't really, the mouse probably isn't in the right location. Let me see if I can fix that by using this mouse. Hopefully this mouse is in the right position. So at the 1, that's where you would have 1.7 arc seconds to use. So he says at 2, which is just 1 radius away, alright, so understand that's 1 radius away. Now you saw the images how big the corona was. So he's clearly still inside the corona. So he says he saw stars inside of that corona. I would say those are not, you can't in any sense practically use those images because you know it could be just scatter. But you know you're going to be affected by not only now the atmosphere, but also now the scatter of the intensity of the sun in any one particular location in that corona. Alright, but look at these numbers. So at 1 diameter from the sun, no, it would be this, no, so this is the surface. 1 is at the surface. 2 is, well, it says distance from the sun, solar radii. Jeez. So yeah, it's not terribly clear. So at 1, is he saying it's 1 solar radius from the surface of the sun? So, but look at the number he has there, 1.5 arc seconds. So he's at 1.5 arc seconds. This is like 1.3 arc seconds. So clearly you couldn't have that much deflection at just 1 solar radius. At 1 solar radius. At 1 solar radius away, you're already 1/4 the amount of gravity. So on the surface you have 1.7. He's claiming he has 1.5, okay, a full radius away. And how is that consistent with the truth? So he has this line, he has this pretend that this is how it really works. How can that possibly be true? At 1 radius from the sun's surface, the number has to be 0.4 or 5. 0.5, let's just say for the sake of argument. Well, it'd be 0.6, right? 1.7 divided by 4. No, it's got to be less than 5, so it's got to be 0.4. So realistically, you could only have a 0.4 arc second detection. And he's claiming a 1.3. That's what this line is, 1.3. How could that be possible? And that's at 1, that's more than a radius away. That's at 1.5 radiuses away. How is that number possible? I can't make sense out of that. So if somebody understands how that makes sense, I'd like to hear the explanation, because I don't think that can possibly make sense. So anyway, again, people who talk about this pristine math, I don't understand how the math can be pristine when you're claiming that at 1 solar radius away, he can detect a 1.5 difference when there should only be a 0.4 difference. How does that make sense? How can he detect 3 times the limit of theoretical possibility? Sorry. Smells like bullshit. So I guess I should read this conclusion part, but I'll do it some other time. Discussion. Yeah, I should do the discussion. Alright, but next time. Some other time. So this is the science that's supposed to convince me. I'm irrational because I think this has jumped the evidence shark and such. Alright, till next time, such.